Okay, everybody, here let's try part 2 of our solutions video. This first group of angles, you are just changing from degrees into radians. You would just multiply the degree number times pi and then divide by 180, and that reduces down to these nice fractions here. Many of these are on the unit circle, but not the last two. So 15 times pi over 180 reduces down to 1 pi over 12. And 22.5 times pi over 180 reduces down to 1 pi over 8. All right, so think about this also. Pi over 8 is exactly half of pi over 4, just like 22.5 degrees is half of 45 degrees. So there is some common sense there in math. The next group of problems go in the other direction, changing radian angles into degrees, and that's pretty simple. All you do is replace the pi with 180 and then just divide. So 5 pi over 6 is 5 times 180 divided by 6. So that reduces down to these numbers here. And hey there, how's it going?
Okay, how are you?
Good. Making a little video here for my students.
Oh, good.
Yeah. That's our custodian right here. He's helping out today and this afternoon. Hi. Okay, so back to the math problems here. These angles are pretty easy to do. All you do is replace the pi with 180 and divide, and you get these numbers here by doing that simple process. All right. The next group of problems, finding the arc length of these circles. Also pretty simple using this formula right here. Very simple formula. I hope you've got that written down in your notes and you can use it on our test. The arc length is just the radius times the angle in radians. It's got to be in radians, folks, otherwise the formula doesn't work. So here we go. Radius is 8, angle is 3 pi over 4. 8 times 3 pi over 4 is 24 pi over 4. That reduces down to a nice 6 pi. And the other one, the radius is 3 and the angle is pi over 3. So 3 times pi over 3 just cancels out the 3's and you're left with just pi for the arc length. The next one, the radius is 2 and the angle is 2 pi thirds. So 2 pi thirds times 2 is 4 pi thirds. Pretty simple. Here is the one that's different because we've got 45 degrees. All right, so our angle is in degrees. You have to use the formula with radians only. So pi over 4 is 45 degrees. So we're going to take our radius times pi over 4, and that gives us 12 pi. The last 4 problems use these other variations on this same equation about arc length, radius, and central angle. And so the first one is finding the angle when you know the arc length and the radius. And that is surprisingly easy. All you have to do is divide. The arc length, 8, divided by the radius, 2. Well, 8 divided by 2 equals 4. And so it's 4 radians is the central angle for that problem. And the other one, the arc length is 24 and the radius is 5. So our central angle is 24 divided by 5, or 4.8 radians. Those are pretty easy. The next two are a little bit more challenging, I think, in terms of just the numbers. It's a simple formula. The radius is just the arc length divided by the angle in radians again. So we've got an arc length of 6 pi and a central angle of pi over 3. So 6 pi divided by pi over 3. And if you remember rules about dividing fractions, you can do that by multiplying by the reciprocal of the one you're dividing by. So 6 pi divided by pi over 3 is the same as 6 pi times 3 over pi. Flip the fraction over. The pi's cancel out, and you got 6 times 3, which gives you 18. And the last problem here, again, the angle is given in degrees, so you should change that to 2 pi thirds, okay? And then do your division. 3 meters for the arc length, 3 divided by 2 pi thirds, well, that'll be the same thing as 3 times 3 over 2 pi. So we're flipping the fraction over and multiplying, and 3 times 3 is 9, 2 pi is on the bottom, so that's kind of an odd fraction there, 9 over 2 pi. But that is the radius of the circle, okay? Let's flip this over and do the last set of problems. The first group here up at the top of the page is all just stuff right off the unit circle. The only one that you had to kind of do anything to is this one right here, where it's 4 times the cosine of pi over 4. Well, cosine pi over 4 is root 2 over 2. So when you multiply that by 4, the 2 cancels out in there. It leaves you just 2 root 2. Okay, so you can check these other answers here. Now the last problems are word problems. Each one of them was a right triangle problem. So we're using our SOHCAHTOA rules here for all of these pretty much. And so in this first one, 128-foot tall tree is making a shadow that's 32 degrees on the ground, and the question is asking what is the angle of the sun, which would be this angle right here in the triangle. So since that's using the adjacent side for the shadow and the opposite for the tree, that would be the tangent function, opposite over adjacent. So the tangent of that angle is 128 over 32. Well, to find that angle, all you do is the inverse tangent of that fraction of the tangent. So that is then the inverse tangent of 128 over 32, and that gives you just about exactly 76 degrees. Okay? Next problem is about a ladder leaning up against the wall, and the ladder makes a 70-degree angle with the ground. And so what we're looking for is how far up the wall does the ladder reach, so that would be like the height, or this side of the triangle, which from that 70-degree angle is the opposite side. So we're looking for the opposite, and we have the hypotenuse. So that would be sine, so katoa, opposite over hypotenuse. So sine of 70 is h over 16. I don't know that it's 15 yet. I haven't figured that out. But there is my equation. Sine of 70 is h over 16. So I'm trying to get the h by itself, so I multiply both sides by 16, and 16 times this, there we are, 16 times the sine of 70 is almost exactly 15. Not quite, but pretty darn close. You could also use the law of sines for this problem. Law of sines works in any triangle. And so writing the sine of 90 over 16 equals the sine of 70 over h, and the sine of 90 equals 1, all right? So that's something that's pretty good to remember there. Sine of 90 equals 1. So I've got h times 1 equals 16 times the sine of 70. So that's h equals 16 sine 70. That's the same thing that we got over here with our SOHCAHTOA equation, and so we still get the same number, of course. In the next problem, again, a 16-foot ladder leaning against a wall, but this time we're told that that sticks out from the wall 8 feet. The foot of the ladder is 8 feet away from the wall. And that is actually a 30, 60, 90 right triangle. And you know that because one leg of the triangle is half as long as the hypotenuse. That only happens on 30, 60, 90 right triangles. So you can take advantage of that shortcut, and since this is our short leg, this is our long leg then going up the wall, and so 8 times root 3 equals the height of the ladder, and we've got our 60-degree angle right there, opposite the longer side of the triangle. Okay, so that one was made pretty easy by those two numbers right there. Look for those shortcuts, folks. All right, this one is a boy flying a kite, and the kite is stretching out the string real nice and straight. It's 450 feet long, and it makes a 42-degree angle with the ground. The question is, how high is the kite above the ground? So again, we've got opposite and hypotenuse, which means we're going to use the sine function. So sine of 42 equals h over 450. So there's our equation there, kind of simplified like that. I multiply by 450, and I get 301 feet for the height of the kite. Okay, enjoy. Bye-bye.